3, 2, 1. Liftoff of the Falcon 9.
Vehicles pitching downrange.
Stage 1 prop is nominal. Stage 1 entry startup. Stage 1 is transonic. Stage 1 landing marine startup. Stage 1 landing leg deploying.
Falcon 9 has landed.
Hello y'all, this is Nectar Spacey. Welcome to my channel. Today is Starlink 6-64 with B-1078 on its 14th flight. I might be wrong. It's B-1076. Let's get into the mission debriefing. Today's launch is Starlink 6-64. The launch time is Friday, May 31st, 2024, 11 p.m. CDT. This is a Falcon 9 Block 5 booster. The booster supporting this mission is a B-1076 landing on a short-fall gravitas for its 14th landing and launch. This is the 33rd day turnaround for this booster. The 326th ever Falcon recovery time of a booster if this booster lands. The mission details: this Starlink Group 6-64. SpaceX launched a batch of their Starlink V2 mini satellites for their second generation high-speed low Earth orbit internet satellite constellation. There are 23 payloads and they're going to low Earth orbit. The location of this launch site is Slick 40, Cape Canaveral Space Force Station, Florida, USA. This will be the 108th orbital launch attempt of 2024, the 357th mission of SpaceX, and the 57th mission for SpaceX for 2024. This will be the 343rd mission of Falcon 9 and the 57th mission total of the Falcon 9 of this year. Thank you for next space flight for that. This booster previously supported Cirrus-26, OneWeb 6, or previously supported these missions. Cirrus-26, OneWeb 16, Starlink 6-1, Intelsat 4E/Tempo, Starlink 6-3, Starlink Group 6-6, Starlink Group 6-14, Starlink Group 6-21, O3 BM Power 5 and 6, Over Zone 3, Starlink Group 6-40, Elutsat 36D, Starlink Group 6-40, 6-54, and Starlink Group 6-64, which is this mission, will be its 14th flight. Actually, let's watch the first flight of this historical booster and its great achievements or the great first inaugural flight of this booster that made its way all the way until now.
Into contact with the warmer air, it condenses into white clouds.
In about 24 seconds, Dragon transitions to internal power. Falcon 9 computers will enter startup mode, which is when the Falcon 9 flight computers will take control of the countdown, guiding the rocket through the last seconds before liftoff. And at that moment, we will hear a call out saying Falcon 9 is in startup and Dragon is in countdown. So let's wait for that.
Falcon 9 is in startup.
Dragon is in countdown.
All right, so both stages are now pressurizing for launch. We will next hear at T-minus 45 seconds the SpaceX launch director Mike Taylor verifying go for launch.
Go for launch.
All right, range remains go for launch. Weather is a go. Today will be the first flight of both the booster and Dragon spacecraft.
T-minus 30 seconds.
At launch, the International Space Station will be 260 miles in altitude, flying south of Nuremberg, Germany.
Stage 1, pressing for flight.
15 seconds.
All right, here we go.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power. And liftoff of CRS-26. Go Falcon and happy Thanksgiving ISS.
That's right, liftoff of SpaceX's Falcon 9 rocket for the 26th cargo resupply mission, bringing new science experiments and solar arrays to the International Space Station.
See Falcon 9 carrying CRS-26 on its way to the International Space Station. We are throttling down the engines on the first stage, and this helps us prepare for max Q, which is maximum dynamic pressure. It's the largest structural load that the vehicle sees on ascent, and we should be passing through that period. In a few seconds here. That call out that we passed through max Q. Great views there of Falcon 9 carrying NASA's CRS-26 mission. We are coming up on a few events happening back to back. That's going to be MECO, or main engine cutoff, as the first event. That's where all 9 of the M1D engines shut down on that first stage, all 9 of those engines that you see lit up on your screen there. And that's in preparation for the next event, which is stage separation. That's where the first and second stage separate. The first stage will flip around and make its way back down to Earth and land on our drone ship named Just Read the Instructions, while the second stage ignites its Merlin MVAC engine to boost Dragon to low Earth orbit during SES-1, or second stage engine start 1. Then the last event is the boost back burn to reduce the velocity of the first stage in preparation for atmospheric re-entry. And that whole sequence takes about 30 seconds, and we are coming up on those few events happening here in a few seconds.
And MECO. Stage separation confirmed. Stage 1 boost back startup. Stage 2 ignition.
Some really cool views there. We had MECO, stage separation, the MVAC engine lighting up on your right-hand screen. We also saw the first stage kind of in the view of the second stage view there, falling back to Earth, doing a flip, and now in its boost back burn. Now that burn lasts about 30 seconds long.
Stage 1 boost back shutdown.
And there's that call out, and the boost back burn has shut down on the first stage. That is the left-hand screen. That's a view of the first stage there. On your right-hand screen, a view from the second stage looking at our MVAC engine. And you can see on your screen, on your left-hand screen, the grid fins are deploying on that first stage. Very cool views. You're watching a live webcast for the 26th commercial resupply mission to the International Space Station for NASA. This is SpaceX's 54th mission for 2022 and the 5th Dragon flight to the International Space Station just this year. Now, we lifted off just about 4 minutes ago from Kennedy Space Center at Launch Complex 39A. And so far, both vehicles on nominal trajectories. Again, on your left-hand screen is a view from the first stage. On your right-hand screen, an awesome view of the second stage MVAC engine with the Earth in the background. For the first stage, in order to make its way back to our drone ship, again, just read the instructions. It has a couple more burns to execute. The first is the entry burn. That's where 3 of the Merlin engines reignite. This helps to slow the stage down as it re-enters the upper parts of the Earth's. Great call-outs there. This entry burn helps to slow the vehicle down as it re-enters the upper part of the Earth's atmosphere. Now, the second burn is the final burn for the first stage. It is called the landing burn, and this is a single engine burn that brings the vehicle's speed down rapidly in order to touch down on the drone ship. Now, you may see some bursts of gas on your left-hand screen. That is nitrogen gas burst for attitude control. And then again, you could see the grid fins. You could see 2 of the 4 grid fins on the first stage. These are hypersonic grid fins positioned near the top of the first stage. So once it's in the atmosphere, stage 1 only uses the grid fins to steer as it makes its way back down to Earth.
Stage 1
now they orient the rocket. They orient the rocket during re-entry and guide the rocket
Stage 1 entry
during
burn
descent.
startup.
For that call out, now you can see on your left-hand screen the entry burn has begun on the first stage.
Shut down.
And there you can see those engines shut down. That concludes the entry burn for the first stage. Again, next up will be the landing burn for that first stage vehicle in just about 30 seconds or so. Stage 2 is still looking good on your right-hand screen. Again, a view from the Falcon 9 second stage looking at the MVAC engine. About 20 seconds away from that landing burn beginning on the first stage. Again, this is a single engine, the center E9 engine burn to help slow the vehicle down just enough to touch down on the drone ship.
Stage 1 landing
just
burn.
read the instructions today. And you can see that the landing burn has begun on the first stage. Let's watch as Falcon 9 touches down on just read the instructions.
Landing like deploy.
Really awesome
Stage 1
views
landing
there. Falcon 9 has touched down, as you can see it standing tall on just read. For an orbital class rocket.
Alright. Looking here. Right on the screen I'm about to pull up. It looks like it's gonna be pretty, calm in terms of weather. What if they have to push the window back, then things are gonna start getting a little bit cloudy, and they're gonna run the risk of losing a launch window for tonight's launch due to either the weather or the boosters problems, or second stage issues, or depending on whatever it is. I'm gonna simulate some flight experiences from Juneau New Orleans real quick. Here you go. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Engines full power. And liftoff. The Falcon 9. The Falcon goes down. Falcon's pushing right. Stage separation and vacuum ignition. Fairing separation. Okay, the booster's doing good. Now at this point, we have stage 1 Griffins deploying. Second stage is still doing good. Engine cut off. Stage 1. Stage 1 entry burner shut down. Stage 1 landing burn started. That's it for the simulation. Looks like the Starlink launch has been delayed a little bit more. We'll be right back. pick it up. I am back. It looks like we got to go. For propellant loading of tonight's launch of Starlink 6-64. Alright, SpaceX said propellant load of tonight's Starlink launch has begun. Alright, my bad. Today, okay, 1 day ago, today was the day that marks this, the 4th anniversary of Falcon 9 launching NASA demo mission from the USA. We are keeping an eye on winds though. As SpaceX said. will read SpaceX's details of the mission. SpaceX is currently targeting Friday, May 31st, for a Falcon 9 launch of 23 Starlink satellites to low Earth orbit for Space Launch Complex 40, Slick 40, Slick 40, at Cape Canaveral Space Force Station in Florida. Liftoff is currently targeted for 10:37 p.m. ET. If needed, additional opportunities are also available on Saturday, June 1st, starting at 7:08 p.m. ET. A live webcast of this mission will begin on X about 5 minutes prior to liftoff. Watch live. This is the 14th flight of this first stage booster supporting this mission, which previously launched 026 OneWeb, launch 816, Intelsat IS-4E03BM power, Ovazone 3, EliteSat 36D, and 7 Starlink missions. Following stage separation, the first will land on the shortfall gravitas, which will be stationed in Atlantic Ocean. At T-minus 38 minutes, SpaceX launch director verifies go for propellant load at T-minus 35 minutes. RP1 loading begins, and at 35 minutes also, first stage LOX loading begins. At 16 minutes before the launch, the second stage LOX loading begins. At 7 minutes, engine chill on the first stage begins. At 1 minute, final pre-launch checkouts are done and pressurization on the vehicle before flight begins. At 3 minutes, or actually at 45 seconds, the go for launch is given. At 3 seconds, the ignition sequence happens. At 0 seconds, Falcon 9 lifts off. One minute and 11 seconds, max Q happens. At 2 minutes and 25 seconds, first stage engine cuts off. And at 2 minutes and 29 seconds, the first and second stages separate. At 2 minutes and 36 seconds, the second stage engine starts. SCS-1. At 2 minutes and 58 seconds, the first stage, or the second stage fairing deployment happens. At 6 minutes and 3 seconds, first stage entry burn begins. At 6 minutes and 24 seconds, first stage entry burn ends. At 7 minutes and 49 seconds, first stage lands. At 8 minutes and 9 seconds, first stage lands. At 8 minutes and 39 seconds, second stage engine cuts off. At 54 minutes and 3 seconds, second stage engine starts. At 54 minutes and 5 seconds, second stage engine cuts off. At 1 hour and 5 minutes and 12 seconds, the Starlink satellites deploy, ending the mission. So, for the first stage, launch, ascent, stage separation, flip maneuver, entry burn, or Ashley Griffin's deploy, entry burn, aerodynamic guidance, vertical landing, autonomous drone ship landing. For the second stage is launch, ascent, stage separation, fairing separation, and payload separation, in that order. Okay. I just found out Starlink Group 8-8 will be launching about 6 hours and 45 minutes before Starship Flight 4. Yeah, that's kind of problematic. Goes U is launching at 4:16 p.m. So be ready for that too. Lots of things to look for. And the weather is not, the wind sound pretty big. But we are in propellant loading. That is currently proceeding for the mission. There's also 2 Starlink launches after this before Starship Flight 4 happened. I'll be streaming 2 minutes at 2 hours and 50 minutes before launch. We are currently T-minus about 4 days and counting until the launch, coming up under 3 days. I'm gonna see if we can get any updates on the launch and see if it delayed or what happened. What's going on? They still has said that propellant oil on tonight's Falcon 9 launch has begun.
tanks are pressing for strong back retract. Strong back lower has started. Stage 1 LOX load complete. Stage 2 LOX load complete. Gas launch closeouts has started. Falcon 9 is in startup. LD, go for launch. T-minus 30 seconds. Seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, and liftoff. Go Starlink, go Falcon. chamber pressure is nominal.
Power and telemetry nominal.
Falcon 9 is supersonic. Max Q.
Invac shell has started. Go.
Stage separation confirmed.
Invac ignition.
Fairing separation confirmed.
Vehicles are on a nominal trajectory.
Stage 1 FTS has safed.
Stage 1 entry burn startup. Stage 1 entry burn shutdown.
Stage 2 FTS has safed.
Vehicles are on nominal trajectory.
Stage 1 transonic. Stage 1 landing burn.
Stage 2 in terminal guidance.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
Evac shutdown.
Alright, mission details for this launch. This is pre-fire nice. The launch time for this launch is Friday, May 31st, 2024 at 10:13 p.m. CDT. This is Electron carry launching pre-fire mission 2. This rocket will be launching from Rocket Lab LC-1B, Maha, Peninsula, New Zealand. This will be 109 orbital launch attempt of 2024, the 49th mission for Rocket Lab total, and the 7th mission of Rocket Lab of this year. This would be the 49th mission of our Electron, and the 7th mission of our Electron this year. So let's get into some simulations for this launch. Here's the Electron rocket. Liftoff. Engine cut off. Separation. That's it for the simulations. We can also expect lots of clouds, but no storms. We look up the winds and the anvil clouds for this launch. That's the major peak item we're looking for this launch of Electron.
Just 7 days ago, the first satellite for NASA's PREFIRE mission was launched from right here at Rocket Lab Launch Complex 1 in New Zealand. And today, integrated to the Electron rocket that you see on your screen, is the second PREFIRE satellite ready to launch to space to begin its climate change-focused mission for NASA. My name is Muriel Baker. Thank you for joining us for our 49th Electron mission today. This launch is called PREFIRE and ICE, and we have a liftoff target time today set for 3:13 p.m. local time or 03:13 UTC. Today's launch is the second of two back-to-back launches for the PREFIRE mission. The first launch on Electron took place just last week from the same launch pad to deliver the first PREFIRE satellite to its 525-kilometre orbit. PREFIRE stands for Polar Radiant Energy in the Far Infrared Experiment, and it's a mission designed for a pair of tiny satellites, each about the size of a shoebox, to measure heat loss from the Arctic and Antarctica to help improve climate and ice loss models that better predict Earth's ice, sea level and weather changes. Once the second satellite is deployed on this mission, both 6U CubeSats will lap the Arctic and Antarctica on crisscrossing trajectories. Both will be set at a 525-kilometre altitude and a 97.5-degree inclination for the 10-month mission. The reason for the focus on the polar regions is because the Arctic and Antarctica behave like Earth's thermostat. They vent out to space the excess energy that Earth receives in the tropics, and the difference between the amount of heat that Earth absorbs and radiates is a key influence on the planet's temperature. But how the behaviour of clouds and water vapour at the polar regions affects Earth's climate has been an atmospheric mystery for years, and the far infrared emissions at the poles have never been systematically measured before. This is the goal of NASA's PREFIRE mission. For more on the science behind it, here is NASA.
The Arctic is warming 3 times faster than anywhere else on Earth.
This is a huge problem, in part because that is enhancing melt of the ice sheet. It's leading to enhanced melt of sea ice.
All of the coastal communities around the world are now seeing sea level rise around them and experiencing increased flooding.
It will impact the future generations. They're going to inherit a planet that's going to be many degrees warmer than what we are today.
We need to have better predictions of how sea level will change, how the weather around the planet is going to change. The only way we're going to do that is to understand how the polar regions are responding to climate change.
We have this considerable knowledge gap in our understanding of Arctic climate.
PREFIRE is going to fill this important gap.
PREFIRE, Polar
Radiant
Energy
in the Far
Infrared
Experiment.
So Earth's temperature is set by a balance between the amount of energy the Earth receives from the sun and the amount of energy that it emits back to space.
Most of the energy that is radiated to space from our polar regions is far infrared energy, and we have no modern satellite observations of this incredibly important energy spectrum. PREFIRE will be deploying 2 CubeSats. Over the course of a year, they're going to be measuring the far infrared energy for the very first time that is leaving the top of our atmosphere.
Each of our PREFIRE CubeSats carry something called a thermal infrared spectrometer that looks down at the Earth and gathers energy being emitted from the planet at different wavelengths.
Just imagine a rainbow. When you see a rainbow, you see the different colors in the rainbow, and what happens is light gets dispersed. Similarly, we see the different wavelengths split up, and you can measure each of these wavelengths, and that's what the spectrometer does. It spectrally separates the radiation into different wavelengths.
These wavelengths were going to give us really important information about how the surface is changing in the polar regions, whether that's going from an ice-covered surface to a melted surface, or whether it's going from sea ice to open ocean.
The 2 satellites are going to be orbiting in a polar orbit around the Earth. The first satellite comes along and measures the scene over the poles, and then a few hours later we have the second one come along in a different orbit and measure the same scene, so you understand the impact of how the energy changes in those few hours.
It's really important that we understand how much energy is being emitted by the polar regions, because that defines how cold the polar regions get. And that temperature difference between the warm tropics and the cold polar regions is actually what drives the entire weather system around the planet.
What we want to do with PREFIRE is we want to take these new observations that have never been made before, and we want to improve our understanding of the climate system and improve our understanding of how climate is going to be changing.
Understanding how the sea level rises and how the ice melts is going to help us understand weather events, and that's going to have direct impact on our farmers and agriculture.
There's a real urgency to getting this information now. Things are changing so quickly in the Arctic that we may only have 5 to 10 years to respond to those changes and help protect the property and lives that may be affected by that.
NASA has also partnered with the Space Science and Engineering Center at the University of Wisconsin-Madison on this important climate science mission. We are coming up on T-minus 12 minutes to launch, and very soon our launch director today, Julia Wembacher, will check in with each operator station in Mission Control in Auckland and Range Control at Launch Complex 1 on whether they are green and ready to proceed with launch. So let's listen in.
To all operators, LD on mission code. Proceeding now with the go, no-go sequence, starting with stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC's go.
And VCON.
VCON's go.
T1.
T1 is go.
And GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
And MET.
MET is go.
RF.
RF is go.
And MM.
MM is go.
LD sub.
LD sub is go.
The go no-go sequence is complete. We are currently T-minus 11 minutes and 9 seconds and counting. We go for the terminal count auto sequence at T-minus 10 minutes. From this time onwards, the 3-word procedure is in effect.
All right, that is go from all stations for our go, no-go poll, and the team is ready to proceed with all of the remaining launch operations. PREFIRE and ICE is scheduled for a liftoff time of 3:13 p.m. local time in approximately 10 minutes and 39 seconds from now. Electron is the star of the show today, but I'm sure a lot of you are following along with the development of our new big rocket, Neutron. The rocket engine we've created to power Neutron is called Archimedes, and right now it is sitting on the test stand as the team prepares for it to breathe its first engine fire as part of its upcoming test campaign. Archimedes is much, much bigger than the Rutherford engine behind Electron, and we'll have 9 Archimedes engines for Neutron's first stage, each of them yielding us around 95,000 pounds of thrust per engine, the equivalent of about 3 entire Electron rockets. So the excitement is building at our test facility inside NASA's Stennis Space Center in Mississippi as the team works through the final checks ahead of Archimedes' first hot fire. We caught up with some of them ahead of this monumental milestone.
I'm Nicky Rains. I'm the manager for Rocket Lab's facility here at Stennis Space Center. We just installed the Archimedes engine for the first time on the test facility. So we've got engine system integration. There's piping, valving, wiring going on. That's being worked real time with software. In the control room, the human-machine interface, HMI, that we use to control things. Those things are in the final preps and final checkouts. We're ready now to push the engine through final commissioning and ready for hot fire. Rocket Lab came into NASA Stennis with the lease for the A3 stand. It was a historic stand built for the Constellation program in the late 2000s. We've been able to utilize hardware. We've taken tanks, we've taken valves, existing piping, whole existing systems for gaseous nitrogen, and be able to repurpose those systems and put them to work for what we need. It lets us go faster, it lets us save money, and it lets us get that initial operational capability Archimedes needs. It's great for Rocket Lab as a commercial company to be partnered here with NASA. We get to use this facility, so we're taking advantage of the existing hardware and being able to repurpose parts of the stand, but we also have a community of support around us. There's contractors here who know how to build rocket test stands, welding, piping, major big concrete and steel structures. There's people who know how to make rocket operations work. So we got that community of people here to support us, and it's a great place to be for a commercial company to be in the middle of this with all that support and the ability to run our operation. My sincere appreciation for the team that we have here at Stennis, the team globally with Rocket Lab. We've had support from New Zealand and Long Beach and from Wallop. So they've come together here. We put a ton of work in here in the last year, and to see it all come together should be exciting for all of us. The team deserves a huge congratulations from everybody involved that have gotten us this far.
There has never been a more exciting time to join the Neutron team as we work to get the rocket to the pad in mid-2025. We're on the home stretch to first Neutron launch, but if you get in quick, you can still be part of the team developing a new generation rocket from the ground up. Check out our website for open roles right now across additive manufacturing, vehicle integration, test site operations, and more. Today's mission profile includes all of the usual launch milestones you've come to expect from Electron. At T-minus 2 seconds to lift off, Electron's 9 Rutherford engines on the first stage will light up to power the rocket for flight. The launch pad's hold-down mechanisms will be released, and Electron will begin its ascent right on T0. From there, Electron reaches supersonic speeds in under a minute, and we'll hear that as a call out from Mission Control just before we approach a mission milestone called Max Q, or Maximum Aerodynamic Pressure. Now, once through Max Q, Electron's Rutherford engines will continue firing hot for another minute and 20 seconds or so before their scheduled shutdown at MECO, or Main Engine Cutoff. 3 seconds later, the first stage will separate from the second stage, and Electron's first stage will fall away while its second stage will light up its sole Rutherford engine to carry on with the mission. Up next will be the separation of Electron's nose cone, about 30 seconds after Stage 2 engine startup. Meanwhile, the stage will be continuing cruising along for another couple of minutes before the next mission milestone, a battery hot swap. Now, that's a maneuver that is unique to Electron, which I'll explain more about when we reach it during the flight. After battery hot swap comes the second stage's final actions, shutdown of its engine before the second stage separates from the kick stage, which is what is carrying NASA's PREFIRE satellite. And then within an hour of all of that happening, we will come up to the moment for payload deployment that ends the mission for Electron, but which marks the start of operations on orbit for the NASA PREFIRE mission. All of that is coming up shortly now that we are just under 5 minutes until liftoff for PREFIRE and ICE. It's time to send it over to Mission Control to take it from here for the remainder of the count, and I'll be back with you shortly after liftoff. So go NASA, go PREFIRE, and go Electron.
Stage LD mission code.
LD stage.
Please prepare the stage 1 and stage 2 for LOX top-up. That's Victor 5000 and Victor 5100.
Copy. LOX top-up sequences in work.
PLS LD and mission code.
LD PLS.
Please resume the LOX top-up. That's Romeo 7600 Bravo.
Resuming LOX top-up.
GC LD mission code.
LD GC.
Please reprime the igniter system. That's Romeo 4200.
Understood. Romeo 4300 in work.
LD avionics mission.
Avionics LD.
Sequence 68 complete.
Copy, thank you.
Looking at the clock on our screen, we have had a hold in the count for today's operations. We're just listening into Mission Control now to hear what the latest is for operations.
6 Alpha 8600.
Copy.
And VCON LD mission code.
LD VCON.
Please shift the auto sequence to T-minus 12-minute hold. That's Golf 2400 for you.
Copy that, in work.
So from comms there from Mission Control, it sounds like we are recycling the clock back to T-minus 12 minutes in the count, and we're standing by for more information.
LD stage on mission code.
Stage LD.
Sequence 69, the stage terminal warp check sequence is complete.
Copy, thank you.
As you might notice, the clock is held at T-minus 4 minutes and 45 seconds. That's a hold in our launch operations. And a hold can happen for any number of reasons at any point up to the release of the vehicle hold-down clamps. So what we're doing now is standing by and waiting while the team establishes a new T0.
LD, GC on mission code.
GC LD.
LD is secured on the pad and ECS is enabled.
Please repeat.
The launch vehicle is secured on the pad and the ECS has been re-enabled.
Copy, thank you.
For those of you just joining us, we are currently in a hold for today's Electron launch, but we have 20 minutes remaining in this launch window. So let's sit with Mission Control for an update.
Alright,
First of all, ew, that's nasty!
Yup. Full power. Quarantine. Die. Wait, what? So Electron is in a hold. We are looking for about 18 left until window dies out. So, 2 minutes. Alright, let's go! Woo! Yeah! Son of a glitch! Son of a... Guanji.
And to all operators LD on mission code, just a heads up, we have resumed the count. We are T-minus 15 minutes and 1 second and counting.
You likely just heard there from our launch director in Mission Control that we have set a new liftoff target time of 15:46 local time, which means the team has now recycled and will go into a new go, no-go poll at the T-minus 12-minute mark. So we'll sit here and wait for that update from Mission Control on that go, no-go poll.
And call operators, LD and mission code, I can confirm I'm actively monitoring mission code, LV code, range code, and safety net. And to all operators, LD and mission code, we are proceeding now with the go, no-go sequence. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC's go.
Recon.
Recon's go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
RF.
RF is go.
MN. LD sub. LD sub. LD mission code.
LD sub is go.
Copy, thank you. The go-no-go sequence is complete. We are T-minus 10 minutes and 57 seconds and counting. We go for the terminal count order sequence at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
Good news there from Mission Control. The clock has been recycled and all stations are go for launch. And we are at T-minus 10 minutes, 29 seconds and counting with a liftoff time set for 15:46 local time.
With sequence 55, the paired terminal check sequence.
Understood. Sequence 55 in work. Stage 1 igniter pressures verified, hydraulic pressures verified. LD-GC on mission cord.
GCLD.
LD, the pad terminal checks are complete.
Copy, thank you. Avionics LD mission code.
LD avionics.
Please proceed with sequence 56, the avionics terminal check sequence.
Copy. S-band is switched to high power for flight.
Stage LD mission code.
LD stage.
Proceed with sequence 57, the stage terminal check sequence.
Understood. Sequence 57 in work.
Stage 1 and 2 high voltage batteries ready for flight.
GCLD mission code.
LD-GC.
Please proceed with sequence 58, launch pad ready.
Understood. Sequence 58 in work.
LD avionics mission.
Avionics LD.
Sequence 56 complete.
Copy, thank you.
All engine blips nominal. All engines ready. LD stage on mission cord.
Stage LD.
Stage terminal check sequence 57 complete.
Copy, thank you.
As we can see on our screen, the strong back for Electron is slowly starting to retract ahead of its flight scheduled for 15:46 p.m.
LD GC on mission cord.
GCLD.
Hold down mechanisms are armed and the strong back is retracted for flight.
Copy, thank you.
As we head into T-minus 4 minutes in the count, the next major milestone we're listening out for is the start of the auto sequence, where Electron takes over the count all the way down to T0. So we'll hand you over now to Mission Control to take it from here for the remainder of the count, and then we'll be back with you shortly after liftoff.
LD GC on mission cord.
GCLD.
LD, the ECS is disabled. The pad auto sequence is armed. The pad is ready for launch.
Copy, thank you.
At this time, we got the confirmation for Starlink 6-64 is finished. So the plus count is ended. Plus count ready for Electron, PREFIRE, and ICE. Godspeed, Electron. Now go bomb!
From now on,
he's on drugs!
Red flags on your critical LCCs. Beacon LD mission code.
LD beacon.
Please lock the auto sequence and confirm.
Auto sequence is locked.
Please confirm all expected primary flight computer ASCOs are green.
Confirmed.
We are go for auto sequence start at T-minus 2 minutes. LD is going for launch.
And hold.
To all operators, LD mission code. We are proceeding now with the LV on paired securization and ECS enable sequence.
We've just heard a hold call from Mission Control there, so now we are listening out to hear what the latest information is for launch ops.
Interoperators, LD mission code. At this point we are proceeding with the preparations for LOX detank. PLS LD mission code.
LD PLS.
please proceed with the PLS prep and detank sequence.
Copy, prepping
Sorry,
with
what
PLS
stage?
detank.
Stage 1.
A final update here from Mission Control that unfortunately, with the remaining time left in the window now exhausted, we will have to wave off for today's launch attempt for NASA PREFIRE. We have plenty more opportunities to launch in the rest of the window though, so keep an eye on our social media channels for an update with a new launch date. This is Rocket Lab Mission Control signing off.
That is indeed some sad news. Something catastrophic could have happened due to certain problems on the vehicle. So they're making sure that everything's nominal on the vehicle before the liftoff. He's on drugs. Yeah, Bob's on drugs.